So space switching is a pretty common thing to do in a rig. And one of the things that you can use it for is to create a sort of gravity behavior on certain accessories. If you take a look at the hair of my character, when you rotate the head back and forth, it stays oriented up and down as if it were being pulled down by gravity. And this also works if you go forward or back. But if you were to twist the head along the y-axis, you wouldn't want it to, stay oriented with world space and do something like this, because that would be quite uncanny and you'd end up just counter animating it. So you already saw that in this character it twists with it, but it doesn't inherit the other two rotations from the head. It always just gets affected by gravity. So I'm going to step into a simplified scene to show off the node network that you can use in order to create a pseudo space switch to create this sort of behavior. Okay, so here's my simplified scene. All I have is a placer component, a stand-in for the head component, and a stand-in for the hair component. And as you can see, I've set up the hair and the head control so that they are not oriented to world space. That way I can show you how to deal with that extra bit of complexity. So to start out, let's take a look at what we need as an input for our hair component to have this space switch. So all I have is an input from the head, which would be at the origin, and an input from the placer, which would also be at the origin. I'm not going to explain the input system. If you don't know what sort of system I'm dealing with, you should watch the Cult of Rig tutorials. So let's take a look at what's going on inside of the hair component in order to create this space switch. So I know this looks pretty complicated, but we're going to step through it bit by bit to try and simplify it. So the first thing that we have to deal with is, of course, the translation of the hair control. So in order to get that, all we need to do is take that input from the head and apply our stored offset that we have on the hair guide. And the hair guide is just located, if I can reset all the attributes on the controls, the hair guide is just located where the hair control would be in its neutral position. So we apply that offset to the head input, decompose that matrix, and then plug it into the translate. And now that I'm looking at it, I realized that we could actually just have a vector product there to make this a little bit more lightweight, but this is just a demonstration of the technique. So I'm going to actually hide all of this stuff so that we don't have clutter, since we understand how the translate is coming in. But what about the rotate, or the orientation? So the first thing that we do is we bring in the placer input, and we convert it from a matrix into a quaternion. Then I use a quat invert node to invert that. So of course we take the head and we do the same thing. We turn it from a matrix into a quaternion, and then we multiply the head quaternion by the placer inverse quaternion. And what that gives us is a quaternion that represents the difference in orientation between our placer input matrix and our head input matrix. So maybe it's good to show you that with a little output locator. So here we have the quat product node, and I'm going to use a quat to Euler one just to turn that into an Euler and plug that into a locator. So as you can see, in the neutral position, there's no difference between the orientation of the head and the placer control, because keep in mind, it's not a difference between the actual controls, because clearly there's a difference between their orientation. It's a difference between them including an offset that puts them at the origin in their neutral position. But then, if I were to go into world space and I rotate this, you can see that that locator is twisting because now there is a difference between the placer and the head. But if I were to grab the placer and twist it, it's a little bit tough to see, but that locator did not get rotated because, of course, there's no difference between the orientation of these two because they both got rotated together. Going back into the node editor, then what I do is I take that quaternion and I plug it in to this input quat attribute, but I only plug in the input quat y and the input quat w because that represents the twist along the y-axis only, because that's what we need to deal with. We need to extract what is the transformation that we need to apply this twist, ignoring any of this swinging. So that's what this input quaternion represents. Then I am multiplying that by the original placer. Is this the placer? Yes, the placer quaternion, just so that we are taking that twist and underneath it we're also applying whatever transformations occurred on the placer. Then I have to apply the offset from the hair guide, because of course this orientation is not the orientation that we need to apply to the hair control, because the hair control is not oriented the same as the origin axis. So what we do is we take our hair guide, which stores that offset, turn it into a quaternion, and apply it to that quaternion that we just had, that is the placer rotation plus, in quotations, because it's not really plus, but we're adding another rotation on top for the twist of the head. Then I take that output quaternion, turn it into an Euler so that I can apply it to a locator, and the child of that locator is our control. So to step through that one more time, because I know we got into the individual ones and maybe it'll be helpful to talk about it as a whole. We take the orientation of the head and the orientation of the placer. We get the orientation needed to go from the placer to the head. We get only the twist on the y-axis component from that orientation. So we're saying, what is the difference in twist between the placer and the head? We apply the offset between the origin axis and our hair control, and then we just apply that to a buffer group above our hair control.